So I want to go to back to this problem for a second. I forgot to write in one of the formulas. Even though we used it, I didn't put it up here in the formula list. So always make sure you write down all your formulas. If you realize, oops, you forgot, it was in your head, but you forgot to put it down, just put it down afterwards. And the other formula we used, we said it, was Pythagorean theorem. We just didn't write it down. So a squared plus b squared equals c squared. All right, so now let's go to our next problem, which is going to combine both the isosceles triangle and the right triangle together. So we're going to calculate the distance of all three sides first. Next, show two of the three sides are congruent. And then test Pythagorean theorem to show the three lengths make Pythagorean theorem true. All right, let's call that our show. Because that is very, now your problem each time won't necessarily be your show, right? But on this one, it's got so much information in the question, I think it will be okay. So we're calculating the distance of the three sides. We're showing two of them are congruent. And we're using Pythagorean theorem to show the three lengths make Pythagorean's theorem true. So our question was so in-depth and so specific, we'll count that as our show. Let's graph. So we need to graph the points 4, -1. And we'll label that A. 5, 6. And we'll label that B. And 1, 3. And we'll label that C. And then we'll connect. Right? And it would go in order A to B, B to C, and C back to A. But it's easier for me to draw the lines this way. And really, there's only way. Every point's connected to the other two. You really can't mess up connecting a triangle. All right, so we have the show. We need the formulas. And let's put the formulas right here. Just make sure we don't run out of space. So our formulas, again, if we're going to show that sides are congruent, we need the distance formula. Right, so that's the difference in the x coordinate squared plus the difference in the y coordinate squared. It's a nice little blip in my little radical there. And then, of course, this time we're not going to forget to write down Pythagorean theorem, which is a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. All right, we got our formulas. All right, now we need our work. All right, so we need to find the lengths of the three sides. All right, and this one you have to use the distance formula because none of them are horizontal and vertical. All right, so actually let's label that as AB. All right, so let's find the length of AB. That would be 4 minus 5 squared plus -1 minus 6 squared, which is 4 minus 5 is -1 squared. -1 minus 6 is -7 squared. So that would be 1 plus 49, which is the square root of 50. If you remember, we had this square root of 50 on another problem. So 50, we can factor that to 25 and 2. 25 is not a prime number. That factors to 5 and 5. 1 5 comes out, 1 5 goes away. So square root of 50 is 5 square roots of 2. All right, so now let's find the length of BC. All right, so we've got 5 minus 1 squared plus 6 minus 3 squared. 5 minus 1 is 4. 6 minus 3 is 3. So 4 squared is 16. 3 squared is 9. That's the square root of 25, or 5. And then let's find the last side, which is CA. So that would be 1 minus 4 squared plus 3 minus a -1 squared, which is negative 3 squared. 3 minus a negative 1, that would be 4 squared. And that would be 9 plus 16, which is the square root of 25, which is 5. Now we can see we have two sides congruent. You don't have to do anything to know they're congruent. You can look and see, hey, 5 and 5, right? But we will have to do something to prove that Pythagorean theorem holds, and that's the next part of our work. All right, so now when you're setting it up, which one's longer? Well, is 5 longer or 5 square roots of 2? Well, of course 5 square roots of 2 is longest, right? Because you've got 5 times something else, right? So square root of 2 is about 1.4. So 5 times 1.4 is certainly larger than 5. Plus the two sides that are the same length, well, they've got to be the legs, right? Because the hypotenuse is the largest side in the triangle. So let's do the Pythagorean theorem part. So that's going to be 5 squared plus 5 squared equals 5 square roots of 2 squared. 5 squared is 25. When you square a number times a radical, square the number. So 5 squared, that would be 25. And then square the radical. So times the square root of 2 squared. Right? So square and square root cancel. So that's going to be 25 plus 25 equals 25 times 2. 25 plus 25 is 50. 25 times 2 is 50. So you can see Pythagorean theorem holds. Let's write the proof now, and this one's going to be a 2-column proof. And so I think you might have one like this in your notes. You can follow mine exactly, really. Just change, of course, the measurements to match yours, and change the names of the points, right, to whatever the triangle in your homework is called. All right, so we have triangle ABC is step 1, and we know that triangle exists because it is given to us. Oops. I forgot to write statements and reasons in, and I'm going to run it. I don't have enough space anyway, so if I put statements here, I think I can squeeze reasons in and have enough room for the proof. There we go. All right, so statement, triangle ABC. How do we know there's a triangle ABC? That was given to us. Number 2, we know that AB equals 5 square roots of 2, and BC equals 5, and CA equals 5. How do we know that? We use the distance formula. All right, and we also know that BC is congruent to CA. That was one of our requirements to show it had two sides congruent. How do we know the sides are congruent? Congruent segments have the same measure. Just squeeze that in. All right, so since we have two sides that are congruent, triangle ABC is an isosceles triangle. How do we know? Isosceles triangles have two congruent sides. It's got two congruent sides, must be isosceles. Not only is this an isosceles triangle, we also know that triangle ABC, is a right isosceles triangle. How do we know it's a right isosceles triangle? Because it's an isosceles triangle that satisfies Pythagorean theorem. And let's put next to that converse of Pythagorean theorem. because that's what we actually used. But I'm trying to combine this into one step. All right, so we prove that it has two congruent sides, making an isosceles triangle. We've proved it's a right isosceles triangle because we've showed not only is this an isosceles triangle, but it satisfies Pythagorean theorem using the converse of Pythagorean theorem. All right, and that's the end of this proof. And that's my last triangle proof. In the next video, we'll do a very short circle proof. It's like one on your homework, and that'll be the end of coordinate proofs. All right, bye for now.